Okay, I'm going to assume that you've watched my video or at least gone through the notes on measures of center, measures of variation. I would like to use this Excel file and this worksheet. We're going to go through this worksheet. It's not going to take too long, but I want to use this to sort of accentuate when exactly we should use which measure of center to describe a data set. So the measure of center basically should be a representative value that sort of gives a description or a generalization of the data set. Sometimes we use mean, sometimes we use median. For example, if this particular worksheet is on house prices, so the data you see in column A, let's say this is 12 houses on a street, a little cul-de-sac, one little street, there's 12 houses. You have 11 houses in the $200,000, $300,000, $400,000 range, and then you have one, let's say one big mansion at the end of the street, this $2.2 million. If you go online and you search one of those real estate websites, Redfin.com or Zillow, I believe is one, Zillow.com. All of these websites, they have a whole lot of statistical data that you could browse through. So you could look up, you could do some research. If you're, let's say, for example, if you're buying a house, you're buying a condo, something like this. What you'll see is that, when you pick a city or you pick a neighborhood, you will be always given the median house price. Always. Sometimes they will include the average house price, but most likely that will be, off to the side or might not even be there. They will definitely give you the median, but not the mean. What I want to do in this worksheet is give you one example where the median would be a more representative characteristic or more representative value than the mean. So what I have here in yellow, I want to calculate the mean, the median, the mode, and the mid-range for the data that I have here in column A. On my notes, I talked about mean, median, and mode. The mid-range is, again, like with measures of variation, where I said the range is not used very often, not very informative. In terms of measures of center, the mid-range is the same. It's not used very often. It's not very informative. The mid-range is the halfway point between the lowest and the highest value. So basically the average of the minimum and maximum data values. It's not very important in the context of this problem. So what I want to do is calculate the mean, the median, the mode, the mid-range using Excel, using the built-in functionality of Excel, with and without the outlier. By outlier, I mean this one value that's very far away from the others. I'll highlight it in blue. So this blue cell, the $2.2 million, this is an outlying value or an extreme value. So we'll do mean first. I'll start here in the second column without outlier. So if I want to calculate the mean, on Excel, mean is average. So I'll do equal the average of this data, A1 through A11. So I'm finding the average house price, ignoring the big mansion at the end of the street. So 360,000. If you look at that list and you ignore the 12th value, yeah, 360,000 seems pretty representative. Some above, some below, but that's about average. Now, if we include the outlier, so I'll do the same thing, equal average, but now I'll include all 12 values. Now, in this case, I'm at 514,000 approximately. So by including one outlying value, one extremely high value, I've shifted the mean of the set over $150,000. So from 360 up to 513, 514. So what this means is that a single value, one single extremely high or extremely low value can drastically affect the mean. So we say the mean is not resistant to outlying values. If we do the same thing for the median, I'll do without the outlier first. So equal median. And I'll highlight the first 11 values. The median price is $375,000. So that's the halfway point on the list. And just to, again, show you exactly what I mean by that, let me copy these values over, and I'll take them, I'll put them in order. Oop. So over here on the right, sort A to Z. I'll sort smallest to largest. And I'm going to continue only with the current selection, only with what I've highlighted. So with 11 values, the center number is the median. 5 above, 5 below. So the median value is 375,000. I'm going to go ahead and get rid of that and go back to the calculations. Now to calculate the median here, including the outlying value, including the $2.2 million. So equal median. And I'll highlight all of the data. 380,000. So incorporating one extremely high value, it drastically affects the mean, but it only slightly affects the median. So this tells us that when you're choosing a measure of center, to describe or to represent a data set, if there are extreme values or outlying values or one or two values that are very far away from the rest of the data set, the median is a better choice because the median is what's called resistant to outliers. The inclusion of the $2.2 million house or the $2.2 million data point, it shifted the mean by over 150,000. It shifted the median by only 5,000. Next, the mode. I'll do equal mode. I'll highlight the first 11. So the mode is 285,000 because there are, I'll highlight them in yellow, the number 285,000 is repeated. No other value is repeated, so we have one mode, and it's 285,000. And I will recalculate the mode, so equal mode. Now, including the extreme value, and in this case, the mode doesn't change at all. And that should make sense because an outlying value or an extreme value it's an unusual value. So your outlier is not going to be the one value that's repeated most often. If it's repeated most often, it's probably not an outlying value. So what we see so far is that the median and the mode are both resistant to extremely high and extremely low values. The mean is not. So that means one single value could really throw off the mean. So this mean of 513,000, that is not very representative of the set because all of these houses are well below 513,000. It's this one house, this one $2.2 million house that's really skewing the mean, pulling it towards the high end. And now for the mid-range, I don't think there's a built-in function for mid-range. And statistically speaking, we almost never use mid-range. But just to give you a little bit of practice with Excel, the mid-range is the average between the maximum and minimum values. So there's a function for maximum and there's a function for minimum in Excel. So I could do, it could do this a number of ways, but what I'll do here is I'll take the average of the maximum and minimum value. So I'm going to actually input this function in two steps. I'm going to apply a function to a function. So I'll say equal average. You know what, I'll, before I do this, let me zoom in. So what I'll do here is equal average, and I'm going to take the average of two numbers, the maximum, and I'll just type it in here, A1 through A11, and the minimum of A1 through A11. And then close the parentheses for the average function. So this is telling Excel to take the average of two numbers. Those two numbers being the maximum of the set and the minimum of the set. And I'm only including the first 11 numbers. So this is not including the $2.2 million house. Okay, so 362,500. So the mid-range, the mean, the median, they're all relatively close. So now if I apply that same formula to all 12 numbers, so the maximum of A1 through A12, and the minimum A1 through A12. So now obviously the maximum is $2.2 million. When I calculate the mid-range here, the mid-range is 1,242,500. So the addition of one outlying value, in this case, shifted the mid-range by almost $900,000. So what we see here is that one single extreme value could greatly distort the mean and the mid-range. But the median and the mode are both resistant to outlying values. On my solutions, I have definitions, and basically what I said, what I just said, I have stated here next to each one of these four key terms. I'll pull up my solutions. So if you open my solutions file, this is what you'll see. The mean can be affected strongly by extreme values or outliers. The median is resistant. The mode is resistant. And the mid-range can be strongly affected. Each one has benefits in different situations. For example, if your data is not quantitative, if your data is categorical, you have to use the mode, because the mean and the median are relying on numerical values, mathematical, arithmetic calculations. The mode is just counting. If there are no outliers in your set, the mean is a viable measure of center. If there are outliers, the mean is probably not the best one to use. In this case, we use median. One common technique, actually, and we'll see this later on the semester, one common technique to performing a statistical analysis is to first analyze your data set, identify any extremely high or extremely low values, delete them, and then perform the statistical analysis. In the next topic, I believe it's actually topic 4, we will sort of quantify or establish a very specific cutoff between what is an extreme value and what is not an extreme value, or what is an outlier and what is not an outlier. Okay, so from here, the next place you should go is to my PowerPoint notes topic for, I believe it's percentiles and quartiles. And after that, there'll be another Excel file that sort of goes along with the material in the notes.